and in this video we'll discuss remainder and factor theorem. So normal long division looks something like this. We have 4 here and 8. 9 minus 8 is 1. So in this case 4 is the quotient and 9 is what we call the dividend. 1 is obviously the remainder and 2 is what we call the divisor.
Wow!
Notice that 2 multiplied by 4 is 8, and if we add 1 we get 9. So we can devise a formula which will be applicable for all cases. That is, the dividend is equals to the multiple of the quotient and divisor plus the remainder. Let's make a box around it. And our second example could be 16 divided by 9. 16 divided by 2. So this would look something like this. We have an 8 here, 16 here, and 16 minus 16 is 0. So in this case, the remainder is 0. So this means when the remainder is 0, the divisor, which in this case is 2, is said to be a factor of the dividend. The divisor is said to be a factor of the dividend. So in A levels, we'll do the same thing but involving algebra. So our first A level example will be something like x square minus 5x plus 7 divided by x minus 1. So this here is a quadratic. So in order to divide this, we'll do something similar. We'll write x square minus 5x plus 7 here and x minus 1 here. So we need to multiply x with something which will give us x square. We only need to focus on the first one. So this will be x, obviously. And we have an x square here, and minus 1 multiplied by x is minus 1. So we'll subtract this, and as a result, the signs change. X square will cancel out, the sign will change, and we have minus 4x here. And now we'll divide x by something which will give us minus 4 after bringing down the plus sign. So we'll multiply x, or rather x minus 1 by minus 4. This will give us minus 4x plus 4. We'll subtract the whole thing. The signs will change. So 4x, 4x, minus 4x cancels out. And 7 minus 4 would be 3. So x minus 4 is our quotient. And 3 is our remainder, x minus 1 is our divisor. So, for our second example, we can have something like 3x square plus 2x minus 11 divided by x plus 2. We'll speeden things up a bit. So, we have 3x square plus 2x minus 11 x plus 2. So, we'll have to multiply x by 3x and we'll have 3x square plus 6x here. We subtract the whole thing. 3x square cancels out and we'll be left with minus 4x. We'll bring minus 11 down and now we need to multiply this whole thing with minus 4. So we'll have minus 4x minus 8. We'll subtract the whole thing. Minus 4x's cancel out and the sign of minus 8 changes. So we have minus 3 as a remainder. Now we'll take 3 more examples before we advance things up a bit. So in this example, we'll do the same thing. We'll multiply x minus 2 with x square. So we get x cubed. So we have x cubed minus 2x square. We'll subtract the whole thing. X cubes cancel out. The sign of minus 2x square changes and we have minus x square. We'll bring plus 7x down and we'll write minus x in the quotient. So we have minus x square plus 2x. We'll subtract the whole thing. The x squares cancel out and the sign of plus 2x changes and we have 5x. We'll bring minus 8 down. So we have minus 5x minus 8. We'll multiply x minus 2 with minus 5 or rather plus 5. So we have 5x. 5x and minus 10. We'll subtract the whole thing as always. The 5x cancels out and the sign of minus 10. So we have plus 2. So plus 2 is what we call the remainder and this is what we call the quotient. Now this is our second last example. So in this case, notice the fact that there is no term with x cubed, x square, sorry, x square is missing. Thus, we'll do almost the same thing, but we'll write 0x square. Hmm. So, an x square term is missing here, so we write plus 0x square. Since the x square term is missing, I repeat, we'll have to write it as 0x square. And we have minus 8x square and a plus 7. We'll do the same thing now. 3x square here and 3x cubed plus 3x square. We'll subtract the whole thing. 3x cubes cancel out and we have a minus 3x square here. We'll bring minus 8x down and we'll multiply x plus 1 with minus 3x. So we have minus 3x squared and we have a minus 3. We subtract the whole thing, 3x squares cancel out and the sign of minus 3x changes. Thus we have minus 5x. We'll bring plus 7 down into the room and we multiply by minus 5. So we have a minus 5x minus 5 here. We subtract the whole thing, minus sign changes, minus 5x's cancel out and we have a 12 in the remainder. This is the quotient and this is again the remainder. Now finally, a last example is almost the same, but it's rather simpler. So as example 5, we have 3x cubed minus 5x squared plus 12x minus 10 divided by x minus 1. So no matter how long the equation is, the sequence of steps always remain the same. However, there might be some changes such as introducing a 0x square or something else. But the sequence of steps always remains the same. We'll apply the same steps. Hmm. So we have a 3x square here and a 3x cubed minus 3x square here. The sign of minus 3x square changes as we subtract the whole thing. 3x cubes cancel out and we have a minus 3x square here. We bring the plus 12x down and we multiply x minus 100 minus 2x. So we'll have a minus 3x square here and a plus 2x here. We subtract the whole thing, the 3x squares cancel out, the sign of plus 2x changes, and the steps. So we have 10x here. We'll bring minus 10 down and so we'll have to multiply x minus 1 with 10 and we have 10x minus 10. We subtract the whole thing and both these things cancel out. So we have a 0 here. Again, this, my friends, is the quotient and this is the remainder. And since the remainder is 0, we can conclude that x minus 1 is a factor of 3x square minus, or rather 3x cubed minus 5x square plus 12x minus 10. Now, the thing is that the question might either require us to find both the quotient and the remainder or only the remainder. And these are the two cases we have. So if the requirement of the question is to find the quotient and the remainder, we'll apply long division. But else, if the requirement of the question is only to find the remainder, there is no need to go through the hassle of long division and we simply apply the following steps, which are as well. So the first step would be we will consider the dividend, the number which divides. the number which is divided rather, as the function, and equate the divisor, the number which divides, which in this case was x minus 1, in this case was x plus 1, x minus 2, x plus 2, and x minus 2. These are divisors. Okay, so we will consider the dividend as the function and equate the divisor by 0. Hence, we will find the value of x. And then the second and the last step would be this value of x will then be substituted in the function, and the answer hence obtained is the remainder. So for this case too, we'll take a few examples. I know there have been a lot of examples in this lecture, but please bear with me. So our first example in for questions in which we only have to find the remainder would be x square minus 5x plus 7 divided by x minus 1. So we consider the dividend as the function and equate the divisor by 0, and hence find the value of x, which in this case turns out to be 1. We'll substitute this value of x, and we have 1 square minus 5 into 1 plus 7, and the answer hence obtained is the remainder. So minus 3 is the remainder. No, sorry, positive 3 is the remainder. And our second example would be 3x square plus 2x minus 11 divided by x plus 2. Uh, so we'll take 3x square plus 2x minus 11 as the function in terms of x, and we'll equate the divisor by 0, and x turns out to be minus. We substitute this value of x, and the answer hence obtained is the remainder. So minus 3 is the remainder. And finally, the third example. 3x is x cubed minus 3x square plus 7x minus 8 divided by x minus 2. So we'll assume x cubed minus 3x square plus 7x minus 8 as the function. We'll equate the divisor by 0, and the value of x turns out to be. We substitute this value of x in the function of x, and the answer hence obtained, which in this case turns out to be Wait, let's calculate it. Minus 8 minus 12 plus 14 minus 8. The 8's cancel out and we have, so the answer in this case obtained is 2, and 2 is the remainder. And notice, appreciate the fact that these three examples are same as the first three examples we had in this case. And the remainders turn out to be the same. Now, how about we take our last two examples. So we'll copy this, we'll paste this here. So 3x cubed minus 8x plus 7 is the function of. We'll equate the divisor by 0 and the value of x turns out to be minus 1. We'll substitute this value of x in the function of x, and the answer hence obtained, wait a second, so this is minus 3 plus 8 and plus 7. The answer hence obtained is 12. And this is in, and this is the remainder, and this is in line with the example 4 we had earlier. So we'll take our last and final example before we conclude this lecture. Copy and paste. So, and also appreciate the fact that in this case, since we only had to find the remainder and not the quotient, so we do not have to go through the hassle of long division. Consequently, there was no need to introduce 0x squared. So example 5. 3x cubed minus 5x squared plus 12x minus 10 is a function of x. We equate the divisor by 0 again, and the value of x turns out to be 1. We substitute 1 in the function of. So this turns out to be minus 2. Yeah. So this turns out to be 0. And 0 means that the remainder is 0, obviously. And you also get to know that x minus 1 is a factor of this. And there's the same thing with which you concluded it.